Hello, and welcome to our webinar, Using Visualization to Connect Humans and Analytics in Supply Chain Decision-Making. I'm Bruce Posner, Senior Editor of MIT Sloan Management Review, and I'll be your moderator today. This event will be recorded and will be available to all attendees approximately 3 to 4 business days after the end of the live event. In addition, an abbreviated version of today's slides will be available to attendees. We welcome your questions for our speaker today. To submit questions, please enter them anytime in the chat box in the lower corner of your screen. Or you can submit questions on Twitter using the hashtag MIT SMR event, excuse me. We'll answer as many questions as time permits today. If you're having audio difficulties while listening via computer, please call in via telephone instead, or check the help link in the upper part of your console. Our speaker today is Matthias Winkenbach, a research scientist at the MIT Center for Transportation and Logistics and director of the center's Visual Analytics Lab. Our thanks go out to SAS for their sponsorship of this webinar. And now, on to our presentation, using visualization to connect humans and analytics in supply chain decision-making. Matthias?
Yeah, thanks a lot, Bruce, for the introduction, and welcome also from my side to this webinar on how we can use visual analytics or visualization of data and information in supply chain decision-making. As Bruce mentioned, my name is Matthias Winkenbach. I'm a research scientist at the Center for Transportation and Logistics at MIT, and my role there is kind of twofold. I run a lab on last mile logistics, so a very classical topic in transportation. And I also spearhead that new research initiative on visual analytics that I'm going to talk about today. So let's jump right into the content. And in our work at the MIT Center for Transportation and Logistics, we actually collaborate with industry partners from all over the world, covering pretty much all sorts of industries and sectors. And while a couple of years ago, our project partners' main concern was actually finding the right data to answer some of their most pressing supply chain and logistics problems, the challenge today is no longer really related to getting access to suitable data. Today, data is, like availability of data is pretty much abundant, and companies have access to a wealth of large and diverse sources of data, both internally, so from their own systems capturing, for instance, information about transactions and processes from within their operation, as well as externally. External data sources nowadays may, for instance, consist in publicly available data, such as census information, or crowdsourced data, such as OpenStreetMaps, for instance. Or it may be provided by private third-party like companies like Google or Twitter. And with all of these data sources at our fingertips, our ability to collect data nowadays by far outpaces our ability to actually process that data and to turn it into meaningful and actionable insights quickly. So many of our research partners actually struggle with separating the signal from the noise. That means finding out which data is really relevant to their decision problem and which is not. And for applications in supply chain and logistics management, validating and interpreting data and the outcome of any data analysis requires rich context information, rich experience and intuition and domain-specific knowledge that is actually very hard to encode into purely automated data analytics applications. So that is why in our field it is increasingly important to include the human decision maker early on in any complex data analytics process. Besides the increasing difficulty associated to finding the right data to work with in that wealth of possible sources, and the difficulty associated to interpreting and using that data in a meaningful way, another big challenge actually lies in, let's say, modern and data-driven decision-making being communicated and And so communication based on data is becoming increasingly difficult. And both supply chain and logistics practitioners and academics like our team at the MIT Center for Transportation and Logistics are confronted with increasingly complex stories to tell and insights to convey based on what the data is telling us. So having access to increasingly large, diverse, fine-grained and sophisticated data sources obviously comes at the benefit of being able to explain things at a higher level of confidence and to explore phenomena at greater depth and to investigate decision problems from a wider, more comprehensive set of perspectives. But all of this comes at the cost of the analysis process, the methods used, as well as the findings that come out of it to be more complex, less intuitive, and therefore less straightforward to convey. The value that a company nowadays can extract from so-called big data analytics therefore very much hinges upon having the right tools to also communicate the analytics process and the corresponding findings to decision makers and to other stakeholders. In other words, there's no point in really conducting sophisticated big data analytics if your only tool of communicating about data are things like Excel spreadsheets. And this is why, from our point of view, effective data analytics is becoming increasingly contingent on appropriate means of information visualization. Now, in the academic literature, the term visual analytics was actually coined not very long ago to describe the interdisciplinary science of analytical reasoning supported by visual interfaces. The underlying notion of that research and of any visual analytics initiative is to enable better, faster, and more actionable results from advanced data analytics by combining the specific strengths of computerized analysis and human perception, intelligence, and intuition in an integrated analysis approach. Because purely automated data analysis obviously makes use of the fact that recent advances in computing power and advances in data storage make computers and algorithms actually very powerful and efficient in processing extremely large amounts of data. Such data sets could, in their entirety, for instance, not be perceived or understood by any human decision maker just through purely visual inspection. However, fully automated computerized analysis actually suffer from the fact that many real-world problems, especially in our domain, in the supply chain logistics domain, are not sufficiently well-defined from the very beginning. That is, we often can't even clearly and unambiguously specify the structure, the method to use, the objective, or even the constraints of an analysis beforehand. We need to first explore the available data and run through several iterations of formulating a problem before we properly capture the essence of the real situation that we are trying to resolve. Moreover, when it comes to finding optimal solutions to a problem, computerized algorithms often get trapped in what is called local optima. That means a computer may find solutions that are best in comparison to alternatives that are, let's say, close by. That means very similar to the currently found solution. But that algorithm may fail to realize that the currently found solution is actually inferior to alternative solutions that are very dissimilar from the current solution. And that obviously gives rise to issues of trust. Trust of the human decision maker in the results of a fully computerized analysis, because the way the analysis is conducted and the way an algorithm comes up with the supposedly optimal solution usually remains a black box to the decision maker and cannot really validate it or challenged by him. The human mind, on the other hand, is extremely powerful in interpreting data sets of limited size. It is extremely powerful in detecting non-trivial patterns, non-trivial trends in such data sets and interpreting them in light of a rich set of reference points. Those reference points might be stemming from experience, from human awareness of the context of a decision, from intuition and domain-specific knowledge, or maybe even just common sense of the human decision maker. And a key enabler to exploit the full potential of human perception and cognition for the purpose of data analytics is actually visualization. Very few people think in numbers or data tables. Most of us are actually programmed to associate quantitative information with some physical representation when we build our mental model of a data-driven decision problem. Effective visualizations of quantitative information thus lend assurance to the human decision maker. Assurance that, for instance, before any analysis is even performed, the underlying data is actually valid, it's actually complete, and it has been cleaned and aggregated appropriately. It further enables the human decision maker to explore and discover relationships that may be hard to detect starting from any default assumptions that are typically made, for instance, in statistical modeling. And last but not least, visualization is also incredibly effective to communicate the results of an analysis to various audiences in a way that is tailored to their background and tailored to their technical understanding. The perceptive and cognitive abilities of humans are obviously limited to processing data sets that do not exceed a certain size. That is why human reasoning needs to be supported by computerized analysis and appropriate visual representations of the results of those analyses. And creative, effective data visualizations is also usually not a very easy task. It requires companies to invest in heavily trained specialists in this field, which is typically quite expensive. So the key question here is therefore how to find the right balance between computerized analysis and human interaction through data visualization in the course of such an analysis. Now, with this question, as you might already guess, the answer is it depends. More specifically, it depends on three main factors: the problem, the data, and the user. For instance, well-defined problems with very large data sets or very large sets of underlying data that do not really rely on rich context information to steer the analysis, do not really rely on human interpretation, may call for a strong emphasis on computerized analysis, given that the user is experienced in understanding and validating the results from such an analysis. If the problem, however, is less clearly defined, comes probably with limited or incomplete data, and therefore relies heavily on human context provision and interpretation, a stronger emphasis may need to be put on interactive visualization of data and results along the way. So these three factors, the problem, the data, and the user, define the trade-offs that organizations need to make when choosing between complete computerization of an analysis and extreme levels of interactivity through visualization on the other end of the spectrum. The optimal level between the two will then be determined by the amount of resources that are required to obtain a better or potentially even the single best solution versus the potential costs and risk associated to working off a good, yet probably still suboptimal solution. And moreover, the choice of an organization should also be driven by how efficiently the analysis needs to be conducted and how effectively its results can and even should be turned into action. Now, most existing decision support systems that we see being used in practice, for instance, at our project partners, are currently very heavily focused on purely descriptive analysis that support the recognition and characterization of existing problems. However, practitioners often lack the appropriate prescriptive tools that would allow them to efficiently generate, analyze, and evaluate alternative solutions to the problem that could then be effectively implemented. With increasing complexity and increasing high dimensionality of real-world problems and the underlying data, the generation and evaluation of fruitful alternative solutions is becoming increasingly difficult, and that calls for decision support systems that actually optimally leverage both computerized analysis and human interaction. For future visual analytics applications to fill this gap, they need to provide powerful yet intuitively understandable visualizations of information on the one hand, but visualization is not enough. They also need to provide rigorous prescriptive analytics capabilities on the other hand to really fill this gap appropriately. And I think that leads us to the first question that we wanted to ask the audience, Bruce.
Let's go to the first audience poll. To what extent is your organization using information visualization systematically to support analytic reasoning and decision making? I expect, Matthias, that many of our attendees will be interested in seeing how other people are responding and what the potential is for improved data visualization here.
Personally, I'm very curious whether actually this audience reflects what I've seen in our project practice, because we work with a lot of companies and some of them might even be on the line right now, but I'm curious to see whether the results will actually mirror what we see elsewhere.
Okay, I think we have the results here. I'm wondering if there's anything in these numbers that surprises you. Is this pretty much in line with what you had anticipated, and what
Yes.
what you and your team have been seeing?
Yeah, this is pretty much what we've been seeing. So most of our project partners, be it in the private sector or in the public sector, are usually somewhere in the top 3 buckets. Actually, very few companies have very structured and standardized approaches to using visualization as a means of decision making and as a also problem-tailored approach to decision making. So yeah, I guess most of the people that we work with are also in that green bucket of occasional use of standard static visualizations, which often just depends on the personal preferences of the individual making the decision and not really on the company, let's say, prescribing a certain way of using visualization in the decision-making process. So this kind of also is a good lead up to the next question, namely, what is required for data visualization and visually augmented analytics to actually become a success factor for an organization? And if we look at cognitive fit theory, it actually points out that for visual representation of information to be effective, it needs to correspond to the mental model that a decision maker has of the underlying problem. Now that sounds very academic, but it actually has very real implications. For instance, in our project work with many private and public sector organizations, we observed that the data visualizations employed by practitioners, if they use visualization at all, are predominantly of static nature, and we also saw that in the poll just now. However, most of today's decision problems in this supply chain and logistics management are increasingly dynamic. They are characterized by constant change and the dynamic interaction between multiple aspects of the decision problem. And therefore, the standard tools and methods for data visualization used by most organizations should be revised to reflect the changing nature of the industry context in which they are used. Moreover, we observe that in many companies, effective visualization of data and information are usually seen as a side product of decision making. They are often seen as nice to haves in the best case and probably even seen as unnecessary in the worst case. However, to be a driver of organizational success, data visualization needs to be seen as an inherent part of the analysis and sense-making process and as an important facet of the decision-making culture of the company. Data visualization needs to be made accessible and used at all levels and across all functional units of a company, as it helps to democratize knowledge. It helps to democratize data and information across the organization, regardless of the role and the technical background of the user of that information. A few days ago, I was actually on the phone with the head of innovation of a global freight forwarding company, and during that conversation, he made a remarkable comment that I wanted to mention here, saying that for data analytics to become a really disruptive element for our organization, it can't just be limited to the job description of a few supply chain experts. It can't just happen in the back office of the supply chain division. It actually needs to make it to the boardroom. And visual analytics, in our belief, by combining advanced analytics with interactive visualization, may be the key for data analytics to be used for decision-making at the boardroom level. It helps to bridge the gap between sophisticated analytics on the one hand and managers on the other hand who may not have the time or may not have the technical training to really understand every single aspect of a complex analysis, but who do have a tremendous amount of context information and a tremendous amount of experience and intuition that should ideally be integrated into the analysis to achieve more appropriate and more actionable outcomes, actually. Bridging that gap between decision makers and complex analytics is actually of particularly great value in our domain, in the domain of supply chain management and logistics. Because various studies have already shown that while it is costly to establish a strong data analytics culture and capability within a company, the financial and operational performance of supply chain-driven organizations can actually benefit substantially from the day-to-day use of data analytics. The reason for why visual analytics may be a key driver in turning analytics capabilities into performance improvements in a supply chain organization is actually twofold. First, our domain is becoming increasingly complex. You might be aware that in the past, supply chains were traditionally seen as purely linear constructs governed by mostly bilateral relationships, but nowadays the term supply chain doesn't really fit its purpose anymore. Today, we are actually rather dealing with increasingly complex global and multilateral supply networks. Visual analytics can help to aggregate information on a complex supply network where needed, provide a comprehensive overview of the network, and alert the decision maker of specific aspects or elements of the network that require attention. The second thing is that, as I mentioned before, excessive amounts of data are nowadays available to supply chain managers. However, those supply chain managers are usually domain experts. They are not data scientists. So supply chain decision makers are typically building their decisions on heuristics, that is, on approximations, on rules of thumb, informed by their extensive domain knowledge and experience. Many seasoned supply chain practitioners that we talk to actually do not even see value or even mistrust data-driven recommendations from purely analytical decision support tools. And visual analytics can actually help to overcome this, this barrier to the adoption of advanced analytics by providing intuitive information, visualization, and the ability to challenge computerized analysis results through rich interactivity. For example, in our project work, we found that managers need easily accessible tools to challenge and validate computerized analysis results to build trust. And even if they manage to break a model, and that happened to us quite a few times, but if they manage to break a model, that is actually something that's perceived as something positive, because it gives managers a better feeling for when to trust the analysis and when to probably take a second look and use their own intuition. So to help decision makers manage complexity, visual analytics applications generally follow the mantra, analyze things first, then show only the important, then zoom into or filter those results or analyze them further, and then show additional detail, but only show that detail on demand. And some commercially available solutions already follow this approach to support data-driven supply chain decision-making quite nicely. Nevertheless, we actually believe that an important element is still missing in this mantra, and that is it's also missing in a lot of supply chain decision support tools that we see out there right now, and that element is to propose action. And I'm going to illustrate that in a little bit, but what we see out there right now is that many companies have already realized that it is important to have real-time visibility of their supply chain data. So a lot of companies here, we saw an example from a software called Elementum that some companies use, for instance, to create real-time visibility of their internal supply chain data. And they do that because the faster and the more precisely decision makers are informed about disruptions, about risks, or probably even about opportunities within their supply chain, the faster and the better they can react to that. Supply chain data visibility in that sense helps to increase the velocity of a supply chain. And visual interfaces, like the one that we saw here, to supply chain performance metrics and also to relevant context information, provide simple means for decision makers to access that information quickly. Fewer companies have so far taken it one step further and have already developed solutions that allow them not only to be aware of disruptions, to be aware of risks or opportunities within their supply chain, but to actually quickly identify the root cause of these issues. Identifying the root cause of a supply chain issue based on data usually corresponds to the capability of flexibly aggregating and disaggregating information to drill down to the product, to the component, to the raw material, the carrier, or the supplier that may be causing the issue at the very beginning. And providing arbitrary levels of detail on demand while, as you might remember, being a key element of the visual analytics mantra that we just discussed, is actually one of the biggest challenges in designing effective visual analytics tools, because it requires a very close interaction between domain experts in supply chain logistics, but also analytics experts and IT experts. Finally, very few companies already have decision support systems in place that could turn the visibility and the root cause understanding of supply chain issues into actionable recommendations on what should or could be done about them. And to develop such capabilities actually requires the creation of strong prescriptive analytics tools that are integrated into intuitively accessible user interfaces, so that managers can easily use them within their day-to-day decision-making, not just once a year, not just once a quarter, but actually in their day-to-day operations. This is where, from our point of view, industry needs to collaborate more with academic institutions like MIT to develop such capabilities, because it makes their existing efforts and investments into real-time visibility generate greater returns. So we've discussed a lot of things so far, and based on all of these issues, we can formulate probably 3 high-level design requirements that any visual analytics application in supply chain management should fulfill to be beneficial. First, a good visual analytics tool should always provide the decision maker with multiple complementary views on the problem at hand. This allows for audience-specific perception, for audience-specific presentation of the problem, but more importantly, it allows decision makers to investigate supply chain issues from various angles. So different visual representations of the problem at hand, of the data that is underlying the problem, and of the corresponding analysis results actually allow the decision maker to understand and evaluate the problem and potential alternative solutions based on various different metrics moderated by various different visual encodings. This can lead to better, more holistically informed decisions, but it also helps to avoid that the decision maker gets caught in so-called self-confirming reinforcement traps. It ensures, therefore, that a diversified perspective on the analysis is taken rather than approaching the problem through the single lens of a specific but potentially biased single visual encoding of the relevant information. Second, visual analytics applications can only be powerful decision support tools if they allow for rich and intuitive user interaction. Following the mantra of visual analytics that we saw before, the user must be provided with the right level of detail at the right time to avoid cognitive overload by all that information that is available. And so we need a good interactivity engine to create the ability to literally tap into additional details on demand and to allow the decision maker to maintain an overview of a complex decision problem while at the same time having access to all relevant details whenever they are needed. So the user interaction with a visual analytics tool should therefore be designed as visual and as intuitive as possible to keep the user's attention focused on the analysis, not on the technical use of the system. Third, and as mentioned many times before, visual analytics applications need to go beyond pure data visualization. Pretty pictures of data don't by themselves create any benefit. So visual analytics tools need to provide the analytical capabilities that supply chain decision makers need nowadays to, for instance, predict the outcomes of a supply chain disruption or to predict the outcome of a potential reaction to such a disruption. They need to provide the analytical tools to help supply chain managers identify, evaluate, and choose alternative actions quickly based on ideally all the relevant data that is available to that problem. And last but not least, they need to provide the analytical tools to assess the criticality of certain elements of their supply network for instance, the performance or the vulnerability of the entire system before an actual disruption even happens. The 3 design principles that we just discussed basically give rise to a conceptual system architecture that any visual analytics application in supply chain management should potentially follow. The architecture depicted here was actually published by some colleagues from Georgia Tech and Boston University not too long ago. And due to the time constraints of this webinar, I can't go into its very details. But as you can see, it rests upon 3 main components, three core components. First, a visual representation engine that is focused on turning data and analysis results into appropriate visual representations. Then an interaction engine that defines the way a user can interact with the analysis through visual interfaces. And then an analytics engine that actually provides the descriptive, predictive, and prescriptive intelligence to the system. It goes without saying that given this architecture, the development of a powerful visual analytics application is indeed a highly interdisciplinary effort. Besides domain experts in supply chain and logistics, the development of these three core components actually requires research and expertise in various fields, from information visualization to data analytics to human-machine interaction to cognitive psychology. So as we are right now setting up this new research stream, we experience that ourselves. We are coming from a background where most of us are actually, let's say, domain experts, and now we need to find colleagues to collaborate on that have the necessary expertise in all those other fields, which is interesting, but at the same time challenging, and is also something that any company would face as they engage in developing visual analytics tools for their own decision making. So at the MIT Center for Transportation and Logistics, and more specifically at the other lab that I am directing, the Megacity Logistics Lab, we collaborated with the Media Lab and developed and implemented a visual analytics tool to support the decision making of one of the world's largest retailers last year. More specifically, for that retailer, we developed a visual analytics tool that supported the design of urban last mile delivery systems for online grocery orders, so something that you and I probably use every day in major cities of the US. As you can see in this video, the system we created very much resembles the previously discussed system architecture. There's an analytics engine that is working in the background, analyzing data subject to interactive user input via a visual interface, while a visual engine provides the user with visual representations of the base data and the effect of his or her actions. More specifically, what you see in this video is actually a user interacting with a sophisticated analytics engine that combines simulation and optimization methods to assess the performance of an urban logistics network. He does so via a highly visual and intuitive interaction engine that gives immediate visual feedback. The user can therefore display multiple levels of supporting information, for instance, as an overlay to the geographic context of his decisions. In this case, we see the market of the San Francisco Bay Area, for example. The user could show things like population density, socioeconomic variables, infrastructure characteristics, traffic patterns, or demand information at a very high resolution and in their real geospatial context. Based on this information, the user can then freely design an urban distribution network by placing items on the map that represent various types of distribution facilities, such as distribution centers, store locations, or locker boxes. And then the analytics engine that runs in the background takes this physical input, computes the expected system performance in terms of market reach, in terms of cost to serve, in terms of service level, and then feeds it back in almost real time through a visualization engine that projects these results as a heat map, in this case, onto the geospatial decision context. So this prototype, while being as simple as it could possibly get, has proven to be extremely effective in letting various different stakeholders in the company's decision on how to design their future urban distribution networks participate in that decision-making process. Our tool actually provided a basis of communication that allowed people from various different backgrounds, from supply chain to finance to engineering to marketing to HR, to provide their domain-specific knowledge as an informal input to the analysis. And this valuable input could have never been incorporated in a fully computerized analysis otherwise. However, this input turns out to be really crucial for the real-life viability of the solution that the system comes up with. So, hoping that you can actually see those videos nicely that I'm currently showing, taking this research and development effort to the next level, MIT Center for Transportation and Logistics is currently creating an entire new physical lab space here at MIT that is dedicated to the exploration and advancement of visual analytics capabilities, but also their application to real-life problems in supply chain management and logistics. The lab will go live in January and will feature, as you can see in this rendering, a multitude of audiovisual equipment, from multi-touch surfaces to smart sensor-equipped screens to augmented and virtual reality devices that will allow for highly interdisciplinary research efforts at the intersection of supply chain management, data science, information visualization, and computer science. We have a couple of initial research projects lined up for this lab, covering applications from urban logistics to humanitarian response to global supply chain management to even abstract research, for instance, in the field of network science. And of course, we hope for this lab to be an important impulse to further advance both the academic research on visual analytics in supply chain management, but also its wide-scale application to real-world decision problems of our private and public sector partners, because we want to have a real-world impact with the research that we are doing. Now, as you saw in the video, augmented and virtual reality technology may actually take a central role in the long-term development of that research in the field of visual analytics and supply chain and logistics applications. In fact, as you can see from this chart, these technologies are rapidly advancing. They are becoming increasingly powerful, increasingly technologically robust, and at the same time they are becoming affordable for large-scale deployment in a corporate environment. And that leads me to the second poll question that we would like to ask you.
Yes, the second question is, which potential do you see for the use of virtual and augmented reality technology to support corporate decision-making? Matthias, the cost declines on that slide are quite dramatic, and based on the economics, this should be a pretty significant factor, don't you think?
Yes, I mean, we already see that those devices, which are currently mostly being discussed in the context of consumer applications, basically gaming and experience applications, are becoming affordable for mass deployment in the consumer market, and therefore also affordable, if necessary and if applicable, in any corporate context. And at the same time, the good thing is not only the costs go down, but actually the quality of that technology is increasing rapidly.
So I think we have the results here.
Mm-hmm. This is interesting, actually.
Is there anything that stands out? Does this match your view on the future use of augmented reality and virtual reality in corporate settings, or?
Yeah, well, it matches my personal opinion, or the opinion of our lab. I'm surprised that so many people in the audience actually agree with the fact that there is potential for AR and VR in industry applications, because probably if we had asked that question a couple of years ago, people would have thought of AR as just being things like pick by vision in a DHL warehouse, for instance, which is AR, but is probably only, let's say, scratching the surface of the potential. And so I'm glad that a lot of people actually believe in the potential of that technology for more advanced stuff. And so that actually is, I'm glad to see this, because then the rest of the presentation is not going to be contradicting the intuition of the audience, because we believe that AR and VR technology indeed has the potential to become the next evolutionary step in the development and application of visual analytics tools in corporate environments. It might not happen today, it might not happen tomorrow, but we do believe that AR and VR devices will be a crucial interface to data and to analytics tools in the corporate future, let's say. First, we believe this technology can help to, as I said before, democratize access and democratize the use of data analytics in a large organization by simply making it mobile, by making it scalable, as well as by providing intuitive means of interacting with data and models through gesture, through gaze, or voice commands, rather than through complicated and counterintuitive user interfaces that a lot of specialized software that is being used today usually comes with. Second, we see tremendous opportunities in the ability to immerse the decision maker into the exploration of data in all three dimensions that are naturally available to the human perception. The ability to move through a three-dimensional visual representation of data can indeed increase the information content that we can convey to the decision maker, while at the same time not running the risk of running into issues of, for instance, visual occlusion or cognitive overload that we very often incur when we try to visualize very complex data sets, for instance, but are bound to only a two-dimensional screen. And third, AR and VR will allow for new levels of virtual and remote presence and collaborative experiences. Decision makers will be able to immerse themselves into virtual models of the true operational environment of the decision that they are about to make. They will be able to become aware of more aspects of that operational environment and to incorporate those aspects into the analysis that they are conducting and the decision that they are making. And they will also be able to visualize the results of any quantitative analysis in the context of the real operational environment that it affects, which boils down again to a huge advantage in communicating results from complex analytics processes. So let me conclude this webinar by illustrating some of these ideas real quickly in the next couple of slides. So for instance, here we see a few first examples of AR and VR visual analytics applications that are being developed, in this case by a startup, for instance, geospatial data analytics, as well as for abstract data science methods such as the cluster analysis that you are probably seeing in this video right now. And these examples these should be some examples that show the benefits of this technology clearly lie in a higher information density that can be conveyed, less visual occlusion, because we add a dimension to the display, and a more natural approach to data manipulation and filtering through more intuitive user interaction modes. Virtual models of real operational environments may also allow for corporate decision makers or public policy makers to base their decisions on richer context information. For instance, imagine an architect or a city planner or an urban logistics manager who may be supported by a visual analytics tool that provides context information, such as the building structure of a city, elevation patterns, the geographic topography, and other things that would otherwise be very difficult to convey, and also very difficult to basically formalize in a purely computerized analysis. And with such a tool, the decision maker could actually make their design or his design choices amidst a virtual model of the real environment that forms the decision of his decision, that forms the context of his decision. Sorry. And similarly, if we take it into the four walls, the implications of, for instance, a process redesign or a layout change of a production line or a new retail store design may indeed be most efficiently assessed by sophisticated quantitative methods such as simulation and optimization models, while being communicated and understood more effectively based on realistic virtual models of these operational environments. So here, AR and VR may prove to be particularly useful for communicating analysis results to various stakeholders within an organization. It may actually open up completely new ways of communicating and deciding upon a usually highly non-trivial, because it's highly data-driven decision problem with people of various technical and professional backgrounds that often do not even share the same understanding of the problem or do not even share the same vocabulary to describe the problem. And that is what we already saw in the prototype with that US retailer that I showed you earlier, that providing a common platform of communication can actually be a key value proposition of virtual and augmented reality interfaces to data and to analytics. So given this, the bottom line is we believe that AR and VR can actually be a key enabler of creating acceptance for data analytics-driven decision-making in large and diverse organizations. And with this, I would like to conclude this webinar. Thanks a lot, everyone, for listening to me.
Thanks, Matthias. And now let's go into our Q&A session. We've received a lot of great questions, and we'll continue to take your questions for the next several minutes. A reminder that you can submit questions by entering them in the chat box in the lower corner of your console or on Twitter using the hashtag MIT-SMR event. So a first question I have that came in was had to do with the overall approach. Is there a methodology being developed to make data visualization a standard approach? And how do we get from occasional use of visualization to more regular use embedded within an organization?
Mm-hmm. Well, the thing about like visualization of complex analytics tasks is that it's very hard to define a standard approach that can be easily transferred from, let's say, one company to another, or from one decision problem to another. What we can do, and what part of our research is about, is how can we standardize interfaces. So how can we basically build a toolbox of potential user interfaces which relates to that interaction engine that I mentioned earlier, that can be plugged together once needed to basically suit a specific use case. However, since data analytics, as I mentioned before, is becoming an increasingly complex task, and data-driven decision-making in supply chain management is becoming increasingly complex, we believe that if a company really wants to generate value out of using their data and visualizing it appropriately, they need to somehow develop a tailor-made approach. That means they need to sit with people like us or someone else to support them to really understand what is the problem that we're trying to solve. Why are we not able to solve that problem with the standard tools of, let's say, office-based visualizations of data that we are used to? And how would a more powerful visualization engine actually look like that connects our users with that sophisticated data analytics process more strictly? Because what we see right now is, I mean, companies already do quite sophisticated data analytics to kind of support decision making. But as I mentioned before, it's very much focused on specialists, on very small groups, for instance, in the supply chain division. It's not happening in the boardroom. For the boardroom, we need an easy-to-understand interface and an easy way of interacting with the sophisticated analytics that happen in the background. But to create those interfaces, they need to be designed specifically for the problem at hand.
Okay. Another question came in. Do you have any suggestions on how to pilot a program in a supply chain setting?
Yes, and that's basically what we do, or what we did with that retailer last year, and what we are currently doing with other project partners. We typically try to isolate a problem that is currently probably being solved suboptimally by our research partner, and that is, however, a recurring analysis that they need to run frequently and want to create better interfaces for. And then we isolate that problem. We try to sit with our project partners and really define every single aspect of the decision that needs to be made. Because if you remember the visual analytics mantra, you don't want to overcomplicate things from the beginning. So you basically need to sit and define what is the top level visibility that I need to get with respect to this problem. And what are then the details that I need to be able to pull up on demand, and what are the prescriptive analytics that I really need? So what are the insights that the model should basically provide me with? And then what you usually do is you isolate the problem to, let's say, a geographic scope or a business division, where you are sure that you have the necessary management support, where you're sure that for developing this first prototype, you have a decent basis of data at hand, so that you can actually focus on the development of the interfaces and the analytics engine in the background, rather than dealing too much with, for instance, collecting the data in the first place. We are doing this right now. For instance, we are working on a project that will eventually be a real-time global supply chain visibility and analytics platform, but right now we broke it down to smaller, easier sub-problems and work with static data to just develop the application first.
Can you tell us, this is another question, can you tell us about some of the leading companies that are bringing some of these interfaces to life right now?
Well, I think one company that is probably worth mentioning here is Flextronics, or previously Flex. They are really, I think, one of the pioneers in this domain, even though actually they are not a data analytics or data visualization company. They are a supply chain company. But they created a system internally which they call FlexPulse that basically covers the first two layers that I mentioned earlier. They have very good real-time visibility of what's going on in their supply chain, they have a great system that allows them to aggregate and disaggregate data to drill down to the root cause of potential disruptions. But they're also still lacking the ability to basically combine that with predictive analytics, and that's where people like us come into play to make those systems even more powerful. And there's other people out there. So GE has a similar platform, and the software that you saw in one of those videos, Elementum, is by now an independent company that was, however, basically spun off the developments at Flex.
Another attendee wanted to know, how do you extract tacit experiential knowledge into a form to apply it to analytics visualization?
Tacit experiential knowledge. I'm not sure what that, what exactly that means, to be honest. But experiential knowledge, I mean, the way I interpret this question is, for instance, a colleague of mine is thinking about how are we designing the future or the retail store of the future? How are we designing, let's say, the store layout of the future? And previously, this research question was partially answered by building mock-up stores and having complicated and costly, let's say, focus group studies on how this new store layout would, for instance, be accepted. And what we see in the future is that actually, especially with AR and VR coming up, those interfaces might not only be interfaces that help people perceive data and perceive information, but we might also use them the other way around to understand how people perceive data and how people make decisions based on information by, for instance, tracking their movement, tracking their gestures, tracking where they are looking first and how long. And all of this is possible with the technology that's already out there and is currently probably underutilized.
Someone wanted to know, this is the question, one of the biggest questions about analytics and data overall is who owns the data.
Mm-hmm.
Visualization doesn't really solve that problem, does it? Or is there a view that you have on how to deal with that?
That's true. It's a big challenge that we also see in a lot of our project works. And obviously, visualization doesn't solve this problem. But as I mentioned before, we believe that, first of all, visualization needs to become part of a corporate decision-making culture. It shouldn't be limited to small groups within the company. It shouldn't only be limited to, let's say, the top decision makers. It should actually make it down, ideally, to the shop floor level. So everyone, according to their roles, obviously can make use of visualization to access information. And that kind of goes in line with the notion that data within an organization, at least, should become more democratized. Because the more people are actually aware of data that is available within the organization, the more useful that information can become. And a lot of companies are still kind of very protective of data and are not, even internally, not sharing data across functional divisions or across different hierarchical levels. And personally, but also many of the practitioners and managers that I talk to, there's a strong belief that that needs to change, that data and the use of information and data needs to be democratized. And we believe that visual analytics can be a key enabler for that.
Is there any particular field or market that you are targeting to release your visualization dashboard in?
Well, so the beauty of this lab, it's not just a dashboard, but so the beauty of this lab is that it is not only a highly interdisciplinary research initiative, so not only do we work with a lot of different people who might not even know anything about supply chain logistics, but therefore know about data science or computer science, for instance. But also it doesn't only limit us to applications in the supply chain and logistics domain. It could actually be applied to any data-driven decision problem that you might have. There are people out there in urban planning, for instance, who might have an interest in working with us in that lab to solve a problem that might or might not have a direct connection with our domain, supply chain logistics. There might be people in economics who use this for their research and for their decision making. So there's really not one sector or one, let's say, geographic context that we want to focus on at this point. Obviously, we have to start somewhere. So the first use cases, as you saw previously, are very heavily tied to the research that we do anyway. So supply chain, logistics management, network design, distribution planning, disaster response planning, and stuff like that. But in the future, that will not be the boundary of this lab.
Someone wanted to know how do you predict mobile communication will fit into the AR, VR visualization communication phenomenon?
Yeah, that's an interesting point, because mobile communication can benefit this whole thing in two ways. One is probably obvious. The more mobile communication there is, the more rich and the more real-time data sources we can actually, let's say, connect to any application, any analytics application, and that data can literally come from all over the world. The second thing that we see probably as a long-term development of visual analytics and the use of visualization in corporate decision-making is actually, again, tied to virtual and augmented reality interfaces. Because if you think of the example that I mentioned earlier, that control center of Flex, for instance, it's a multi-million-dollar investment into one single room at the corporate headquarters that allows them to interact that nicely with data. But you want to democratize that. You want to push that to every single plant in your supply chain. You probably want to push it to every single country that you're active in. And we believe that once you connect AR and VR headsets, for instance, with strong mobile communication networks, you could actually create that kind of data visibility and access to data analytics anywhere, at any time, and for anyone, because it's affordable. You could literally sit somewhere in the French Alps on a mountain hut, on a cabin, and solve the problems of your global supply chain. So that's our vision, where this might be taken by the use of AR and VR in the medium-term future.
One question that just came in is, can we build reusable visualization components to other businesses, to other business functions like sales, service, and finance? Do you see that developing?
Yes. So when it's about the visualization and the interfaces, that's what I tried to explain earlier, you can standardize things. So for instance, a lot of business problems can actually be kind of thought of as networked problems. So you have some sort of connections between nodes that might be data points, that might be physical locations of your business, that might be customers, that might be markets, and they are connected with each other through some sort of link, through some sort of flow or relationship. So a lot of business problems, if you think about it, can actually be boiled down to a network problem, a graph problem. So you can design visual interfaces that help you visualize graph-based or network-based data, and that help you zoom in and zoom out of specific details of that data dynamically through a nice visual interface. The analytics in the background, so basically the analytics engine that makes sense of that data and creates, let's say, those predictive capabilities that I was talking about in the webinar, that is something that's pretty much tailor-made, because that is very problem-specific and can usually not just be taken, let's say, from a supply chain problem. We can't just take that analytics engine to solve a marketing problem. But the visual interfaces, so the interaction engine and the visualization engine, they will indeed be able to be, to some extent, standardized, yes.
I think we have time for one more question, and I'm going to introduce this, the idea of whether blockchain plays any role here. Are you bringing blockchain into your future viewpoint for supply chain and tracking of inventory and raw materials?
Mm-hmm. Well, I mean, yes, it's blockchain is actually something that is very heavily discussed in both the industry and also in the academic field related to supply chain logistics. The problem is, I think we still haven't really fully understood what blockchain actually can mean for supply chain logistics. Personally, I don't see, let's say, an immediate short-term connection between, let's say, the aspect of data visualization and blockchain. But where I do see a connection is actually in the collection and the verification of the data that we are trying to visualize and make accessible to decision makers.
Okay, I think we're going to have to leave it there.
Okay.
I think that's all we have time for. Over the next few days, please look out for our feedback, for our feedback survey that we'll be sending out via email. We greatly appreciate your thoughts and opinions. This concludes this portion of our program. Thank you again to our presenter, Matthias Winkenbach, and of course to our sponsor, SAS. A reminder that a recording of this program and the presentation slides will be available within 3 or 4 business days. Thank you all for attending our program today.
Thank you.